Okay, so f is a function. They give me f prime. They want to know where is f decreasing. So f is decreasing whenever f prime is negative. But I can't make a graph, so when I can't make a graph, sign chart is what I want. So I need a sign chart of f prime. Well, I can't see how to factor f prime, so I'm just going to have to make a sign chart as is. So step number one is to figure out where does f prime equal 0. So I want to find the x value that will make f prime equal to 0. My formula for f prime is x squared minus 2 over x. I need to figure out where this will equal 0. One mistake I see a lot of people making is they look at the answers and try to work backwards. Once in a while you should look at the answers. In fact, once in a while you have to look at the answers. But I would say generally that's not a good idea. Much better to just solve the problem and find your answer. So this is a quadratic type problem, so I'm a little bit flustered here, but I want to get rid of this denominator. So I'm going to multiply both sides by x. If I multiply both sides by x, you don't want to divide by x, because if x equals 0, you'll be making a mistake, but multiplying is fine. So when I multiply, I'm going to get x cubed. When this x distributes, I'll get, these x's will divide out, so I get x cubed minus 2 equals 0. So now I know that x cubed is equal to 2. Now I know if I take the cube root of both sides, x is equal to the cube root of 2. So if I went to make a sign chart now, I have all these different values of x. I know that at cube root of 2, the value of f prime is 0, because that's what I solved here. Now I just need to test on either side. So I go back to f prime, here's f prime, and I simply plug in 0. If I plug in a 0 here, well, that's no good, because, oh, that's actually helpful, because if I divide by 0, that would also be undefined. You have to watch out for that. Let's fix that. It's a little weird looking there. Now I need to test in between. Cube root of 2. Something times something times something has to equal 2. Well, 1 times 1 times 1 is equal to 1. So the cube root of 1 is definitely 1. Therefore, the cube root of 2 has got to be something greater than 1. So 1 has got to be in here somewhere, because the cube root of 2 is bigger than 1. If I plug in a 1, so I put in a 1 in place of x squared, or 1 in place of x, and I figure out that I have 1 subtract 2, which is negative 1. All I care is the negative. So in here, all negative. Pick something bigger, bigger than cube root of 2. 2 makes sense. So I need a little space, so I come over here, plug in 2, square that, subtract 2 over 2, cubed. 2 cubed is 8. This would equal 1. That's a positive value, so these are all positive. If I try something less, so negative 1 would be a good choice. So I come here and try negative 1. Always use parentheses when replacing the x. So negative 1 cubed would be negative 1, minus this would become positive 2. 2 divided by negative 1 is negative 2, but that negative makes it back to positive. So that's a plus. Therefore, these are plus as well. So now I have the sign chart of f prime. On which of the following intervals is f decreasing? F is decreasing whenever f prime is negative. So I have found the interval between 0 and the cube root of 2. Between 0 and the cube root of 2. From 0 to cube root of 2, that's the interval where f is decreasing.